Hey there everybody, this is another college algebra lesson. Today we're in section 2.3 talking about functions. We're going to learn the definition of a relation and learn how to tell a relation from a function. We're going to talk about domain and range, and we're also going to talk about function notation, which will be really useful to you the further you go in math. Let's get started. Okay, first, a really simple definition. A relation is any set of ordered pairs. Now, it can actually be a list of ordered pairs, or it might be an equation from which a set of ordered pairs can be generated. But either way, a relation is just a set of ordered pairs. A function is a relation in which each x value matches only one y value. Now, in example 1, all we're going to do is look at each set of ordered pairs and decide whether it's a function or not. Remember, a function is a set of ordered pairs in which each x value matches only one y value. So this 1 only matches a 2. There are no other ordered pairs that have a 1. This negative 2 only matches a 4. And this 3 only matches a 4. So the thing is, the x values cannot be reused. The y values can repeat. The x values cannot match two different y values. And so this one is a function. Let's look at G. In G we have the x value of 1 matches a y value of 1, and it also matches a y value of 2, and it also matches a y value of 3. The fact that the x value 1 matches more than one y value means that no, this is not a function. And when we look at H, the x value of negative 4 only matches a 1, but the x value of negative 2 seems to match two different y values, so H cannot be a function. Now here's just another way of representing a relation. We have here all of the x values and here all of the y values, and the arrows indicate which x values match which y values. And remember, to determine if something is a function, we just want to make sure that each x value only goes to one y value. So in this case, the 1 only matches a 2, the negative 2 only matches a 4, and the 3 only matches a 4. So this is a function. But when we look at H, the negative 4 matches a 1, but the negative 2 seems to match two different y values, and so H would not be a function. Now let's talk about domain and range. Domain is the set of all x values that can be plugged into a relation and give a valid y value, and the range is the set of all y values that can be outputs of a relation. So in example 2, let's look at these different relations and decide what the domains and ranges are, and we'll also practice deciding whether they are functions or not. In part A, we have 3, -1, 4, 2, 4, 5, 6, 8. Now the domain of this relation would just be the x values, and if an x value repeats, we still only need to list it one time. So the domain here is 3 and 4 and 6, and notice we use our curly braces for that because you don't want to use brackets or parentheses, because remember, those are associated with interval notation, but here we're making a list of numbers, and so we use the curly braces. And look here, where they had a list of ordered pairs, they use the curly braces for that as well. Okay, so that's the domain, just a list of x values, and the range will be the list of y values, so it'll be -1 and 2 and 5 and 8. Now we want to think about whether this is a function or not, and the question is, did any of the x values get used twice? And the answer is yes, they did, so this cannot be a function. Now let's look at part B. We have the x value of 4 matches a 100, the x value 6 matches a 200, the x value 7 matches a 200, and the x value -3 matches a 300. So I don't see any x values that are matching two different y values, so this is going to be a function. Let's list the domain. The domain is all of the x values, and let's list the range. The range is all of the y values. And like we said, this is a function because each of the x values is only used one time. Here's yet another way of representing a function. We can have it in a table. So here are all the x values and here are all the y values. Now the x value -5 only matches a 2. The x value 0 only matches a 2. And the x value 5 only matches a 2. Now even though the y's keep getting reused, each x value is only matching one y value. So this is going to be a function. The domain will be all of the x values. And the range will be all of the y values, which there's only one y value, so we only need to put it down one time. And then we can say that this is a function. Okay, now most of the time when you're dealing with relations, you don't have a list of ordered pairs because there's usually too many ordered pairs to make it convenient to do it that way. Usually we either have an equation or a graph. If you have a graph, the easiest way to tell if a relation is a function is to use the vertical line test. In the vertical line test, if every vertical line you can draw intersects the graph of a relation no more than one time, then the relation is a function. Let's look at an example or two. This says, give the domain and range of each relation. Use the vertical line test to determine if the graph represents a function. Okay, now this relation is just these 4 separate points, and they've drawn the red and blue lines to help us figure out where the points are, but the red and blue lines are not part of the relation. The points themselves are the relation. So let's list the domain. The domain will just be each of the x values. So -1 and 0 and 1 and 4. And the range will be each of the y values, 1 and -1 and 2 and -3. And now, any vertical line we draw can only intersect the graph one time. So this is a function. Here's another graph, and we'll do the same thing. Now this time, there are too many points to try to list them all because we'd be here literally the rest of our lives if we tried to list them all. But what we can do this time is list an interval. For the domain, list the smallest x value to the largest x value. And when you do that, it's assuming that every other point in between those two is part of the graph. And that is the case here. So the smallest x value is -4 and the largest x value is +4. This is an interval because we want to include all the in-between x values. So we'll write the domain is bracket -4, comma, +4, bracket. And remember that because we're using interval notation, all of the in-between points are assumed. Now for range, again, we want to use an interval because we want to include all of these points, but we don't want to have to list all of these points. So the range will be the smallest y value to the largest y value. So the smallest y value looks like -6, and the biggest y value looks like +6, and that's our range. Now, to determine whether it's a function or not, we just need to draw a vertical line. If a vertical line can be drawn so that it intersects the graph twice, then it fails the vertical line test and we do not have a function. And that's easy. Of course, the y-axis itself is a vertical line. And you can see that almost any vertical line we draw will touch the graph twice, so this is not a function. And we'll go ahead and get this last one. Same instructions. Now this is a straight line, and so notice that we have these arrows that indicate that the line continues forever in either direction. So when we think about the domain is all the x values as far as you can imagine to the left, and all the x values as far as you can imagine to the right. So the domain here is every number between -infinity and +infinity. And for the range, the same thing. Remember, range is the lowest y value to the highest y value. Clearly, the y values can be as small or as large as you can imagine. So the range will be -infinity to +infinity. And if you try to draw a couple of vertical lines, you'll see that any vertical line you draw will only touch the graph one time. So this is a function. And part D, Same instructions. First, domain and range. Now remember, domain is the furthest left x value to the furthest right x value. It looks like this graph would go off as far as you could imagine to the left or to the right. So the domain will be negative infinity to positive infinity. Range is the lowest y value to the highest y value. In this case, the lowest y value appears to be negative 3, but the graph appears to go up forever, so the highest y value is going to be infinity. We'll say negative 3 to infinity. And we have a bracket on the negative 3 because we do have a point on the graph whose y value is negative 3. So we do want to include negative 3. And now, can we draw a vertical line that touches the graph more than one time? The answer is no, we could not. So this is a function. Now the next thing we want to do is figure out how to look at an equation and determine what the domain and range should be. So we need to have an agreement about what we mean by domain. In general, the domain of a function, defined by an algebraic expression, is all real numbers except those numbers that lead to division by 0 or lead to an even root of a negative number, which would be an imaginary value when you evaluate it. So basically, we can't let any denominators equal 0, and we can't let the expression under a radical of an even root be anything less than 0. We can't let what's under the radical of an even root be negative. In a college algebra course, when we're talking about finding the domain based on an equation, usually we only see 3 types of functions. They are polynomial functions, radical functions, and rational functions. So we're going to look at each of those in detail one at a time. Polynomial functions, very simple. The domain of a polynomial function will always be negative infinity to positive infinity, because a polynomial is just a string of terms where each term has an x power that's a positive whole number. So any number can be plugged into these things, and they don't have any places where they go undefined or imaginary. So really there's nothing we need to leave out of the domain, and the domain will always be negative infinity to positive infinity. Now with radical functions that are even roots, we need to leave out of the domain any values that would cause us to try to take the square root of a negative or the fourth root of a negative. You can't do the even root of a negative because it's imaginary. So when we find domain here, it's only going to be the values that keep the radicand either positive or equal to 0. Equal to 0 is okay. Less than 0 is not okay. So you're going to take the radicand and make it either greater than or equal to 0. Solve that, and the answer to that inequality will be the domain of your function. In other words, the domain is all the numbers except those that make the radicand negative. Now for rational functions, we don't have to worry about imaginary values, but we do have to worry about the denominator being equal to 0. So the domain of a rational function is all the numbers except the numbers that cause the denominator to equal 0. If you'll just set the denominator equal to 0 and solve that, that tells you what values to leave out of the domain, and then the domain will be all numbers except those that made the denominator equal 0. Now let's look at example 5 together. This one says, decide whether each relation defines y as a function of x and give the domain and range. Now, looking at an equation and figuring out what its domain and range are can be a little bit intimidating at first, so I want you to be patient with yourself and maybe come back to this example several times and think through it several times so that it will stick with you. It's one of those things that comes and goes until you have a really good hold on it. Okay, the first one says y equals x plus 4. First, let's determine if this is a function. All we need to do is ask ourselves, is it possible to plug in an x value and have that x value produce 2 answers? And the answer, of course, is no. Any x value you plug in is only going to produce one y value, so this is a function. And now let's think about domain. And one thing you might want to do is decide whether you've got a polynomial or a radical expression or a rational expression. And here we don't have a radical, and we certainly don't have x in the denominator, and so this is a polynomial. Notice that if we did have a power on the x, it would be a 1, and so the power of x that we have here is a positive whole number. This qualifies as a polynomial, and we know that the domain of any polynomial is negative infinity to positive infinity. Now for range, we need to think about what are the possible y values we could get from this. And we can produce any y value by plugging in whatever x value we want to. So the range is also negative infinity to positive infinity. Now our second one has a radical, so this is going to be a radical relation. Let's decide if it's a function or not. And again, when you're deciding if it's a function, the question is, will plugging in an x cause me to get two different y values? And again, the answer is no. Any x you plug in, you'll multiply it by 2 and subtract 1 and take the square root, and each x can only produce one answer, so this is a function. And now let's talk about domain. We know for radical functions, we need to make sure that what's under the radical never becomes negative. In other words, what's under the radical needs to be greater than or equal to 0. So I'll always just take this expression under the radical and write after it greater than or equal to 0. When we solve this, we'll add 1 to both sides and divide both sides by 2, and we find out that x needs to be greater than or equal to 1/2 in order for us to be able to get a number out for y. So the domain is bracket 1/2 to infinity. Now let's think about range. Range is sometimes a little harder for people to get their mind around, but let's think about it this way. The range of a function is the smallest y value to the largest y value. Now this is the square root function, so as the numbers under the radical get bigger, the square root of those numbers gets bigger. So the smallest y value we can get is going to be produced by plugging in the smallest x we can. And the smallest x we can plug in is 1/2. What do we get if we plug in 1/2? 2 times 1/2 is 1, and 1 minus 1 is 0, and the square root of 0 is 0. So it looks to me like the smallest y value we can get is 0. And there's no limit to how large the y values could get because there's no limit to how large of an x we can plug in. So the range would be from 0 to infinity. And notice we have a bracket on the 0 because we can get a y value of 0 by plugging in an x value of 1/2. Here's part C of example 5. Same instructions. This one says y squared equals x. Now on this one, before you can determine if this is a function or not, you need to have it solved for y. So we'll have to use our square root property to get this solved for y. Remember, when you do the square root of both sides, you'll need to insert the plus minus symbol. So what we get here is square root of y squared equals plus or minus the square root of x, and that means y equals plus or minus square root of x. Now if you want to think about whether this could be a function or not, remember the question is, does plugging in an x produce two different y values? And here for the first time the answer is yes, it does. Plugging in any number except 0 will produce a positive and a negative y value. So this is not a function. And now let's think about the domain and range. This is a radical expression, so the smallest x we can plug in is 0. We can't plug in any x values that are negative because then what's under the radical would be negative and therefore y would be imaginary. So the domain needs to be bracket 0 to infinity. And the range is all the y values we can get out. Now notice we can get out any negative number and any positive number by plugging in the appropriate x. So the y values seem to go from negative infinity to positive infinity. And only because we have the plus minus here. And now let's look at part E. We have y equals 5 over x minus 1. This is our first time seeing a rational expression. So Now let's think about whether this could be a function or not. Well, any x we plug in, we're going to have to subtract 1, and then we're going to do 5 divided by that denominator, and any x we plug in is only going to give one answer, so this is a function. And now let's think about domain. The only number that cannot be in the domain is the number that causes the denominator to equal 0. If x minus 1 were to equal 0, our expression would be undefined. So x minus 1 cannot equal 0, and therefore x cannot equal 1. So the domain is all numbers except 1. And this is what it would look like on a number line. We would have all the numbers to the left of 1 and all the numbers to the right of 1, and we just would have parentheses here to show that we're leaving out the 1. So this interval is negative infinity to 1, parentheses, and this interval is parentheses 1 to infinity. Now it's critical that you use parentheses here because I see students sometimes use brackets, and when you use a bracket you're including the 1, but the whole purpose of this is to leave out the 1. So let's say domain is negative infinity to 1, parentheses, union, parentheses 1 to infinity. And now range. Now range is a little tougher to get your mind around again, but there's a trick to it. You can achieve any y value you want by plugging in the appropriate x. If x is a number very close to 1, you can get a very small fraction in the denominator, and you can produce a y value as large as you want. If you make x a very small positive number so that that number minus 1 comes up slightly negative, you can produce a very large negative number. So we can get almost any number we want out of this expression. The only number we can't get, oddly enough, is we can't get a 0. Because in order to get a 0 here, the top of our expression would have to be 0, and there's no variable here, so this top number is always going to be 5. We can't force it to be 0, and therefore we cannot make this expression equal to 0, so we have to leave 0 out of the range. And so that's how we would write it, negative infinity to 0, union 0 to infinity. Here are a couple of practice ones that you should be able to think about on your own. So pause the video and give them a little thought, and then I'll talk through them with you. Okay, here we go. Again, decide whether each relation defines a function and give the domain and range. Okay, so to decide if it's a function, what we need to do is decide if any x we plug in can produce two different y values. Well, no, in this case, any x I plug in is only going to produce the square root of one number, so y is one number for any x we plug in, and this is a function. Now, to decide what the domain should be, we just have to remember that we can't let the radicand, or the expression under the radical, become negative. So 4x plus 1 would have to be kept greater than or equal to 0. That means 4x would have to be greater than or equal to negative 1, and that means x would have to be greater than or equal to negative 1/4. So this is our domain, but in interval notation, we would write that the domain is any number from negative 1/4 to infinity, bracket negative 1/4 to infinity. Now let's think about range. Since this is a square root function, as the number under the radical gets larger, the square root will get larger, therefore the y value will get larger. So the smallest y value we can get is going to come from plugging in the smallest x value we can get, and that's negative 1/4. Now, of course, if we put negative 1/4 in here, that's going to equal 0. Remember, we solved it that way. So if we put negative 1/4 in here, that's going to equal 0, and the smallest value we can get out of this radical is 0. So the range goes from 0 to infinity, because there's no limit on how big the square root can get. Now here is another rational function. You can tell because we have a variable in the denominator. And let's decide if this is a function or not. Any value of x that we plug in is only going to give us one answer, so each x we plug in matches one y, and this is a function. Now let's decide what the domain should be. We just cannot let the denominator equal 0. Therefore, we can't let x minus 5 equal 0, and that means we can't let x equal 5. In other words, the domain is all numbers except 5. So we would write that the domain is all the numbers to the left of 5 and all the numbers to the right of 5. In interval notation, the domain will be from negative infinity to 5, parentheses, and from 5 to infinity. Now let's do range. Just like the last rational expression we saw, we can get any number we want out of this expression by choosing an x that's either very close to 5 or very far away from 5. The only number we can't get here is we can't make the top equal 0, therefore we cannot make the expression equal 0. So we have to leave 0 out of the domain. And here we go, negative infinity to 0, union 0